And welcome back, you fabulous math masters, you wonderful fourth graders of virtual room 502 at Hamilton TKA8. Wish we were back there, but this is the next best thing. Problem 2, we're going to multiply a 3-digit number by a 1-digit number, connecting the area model to the standard algorithm. So let's get busy with that. I just checked my TE, which is teacher talk for teachers addition, to see what we're multiplying. And it appears we're multiplying 316 times 4. So I'm going to set that up over here on the top. And yes, indeed, ladies and gentlemen, boys and girls, damas y caballeros, we are copycats. So it's 316 times 4. What will that equal? Well, the first thing we're going to do is make a fabulous area model. And we'll zoom out a little bit. We're ready to make a fabulous area model. I think we are. And let's do a 2-color area model. So what we have going on is a big long guy here. He says I am a big number. This is where the 4 goes, okay? And this number in its entirety is 316. We're all set up, 316 times 4. How are we going to do this? Do it in a little different way than from the last time I showed you. We're going to make a break here, and so on like that. So that's what we're looking at. All right. So what do we do? What do we do next? I'm going to put 3 hundredths here. Can you see that? Yes, you can. 110. 6 ones. So 3 hundredths, 110, 6 ones. That's 316 where I come from. Probably where you come from too. So let's start doing a little bit of math here. Let's say, how should we go about this? Okay, I got it. We're going to go 4 times 3 is 12. And we're in the hundredths, so it's 12 hundredths. 4 times 110, we know what that is. It's 40, right? And 4 times 6 is 24. So this is what we have going on. This is what we have going on, moving and rocking. We're going to do a partial product over here to show this. And let's use a fine pen. And we'll do 316 times 4. And we've already done the math, right? 6 times 4. 4 times 6 ones is 24. 4 times 110 is 40. And 4 times 300 is 12 hundredths. Let's not add it up yet, though. Let's do some more math. So basically what we have going on here is this. 4. And when there's no space, that means we multiply. When it's just a digit, a number in a parentheses, we just go ahead and know it's multiplying. Plus 4 times 300 plus 10 plus 6. Okay, that also equals, and equivalent to this is 4 times 300 plus 4 times 10 plus 4 times 6. There we have it. See how that would be the same thing as 4 times 300 plus 10 plus 6, 4 times 300, 4 times 10, 4 times 6. That's kind of what we did up here. Really both ways. So now we are ready to break this down even further. But first, let's do the partial products. Go ahead and add that up. And we're going to go 4. 2 plus 4 plus 0 is 6. Bring down the 2, bring down the 1. We have 1,268, okay? And one more way we're going to go about this with the standard algorithm is let's do it. I'll show you. I'll show you what to do in the standard algorithm world. Are we ready? We're ready. Watch this. It's going to be a thing of beauty. Okay, standard algorithm. We're going to make another area model. Radio. And then what we're going to do is let's break it up kind of the same way, so it represents the same numbers. And we're going to do the standard algorithm. How about right over here? I'm running out of room again. Watch this. This is really going to blow your mind. Okay, 6 times 4 is 24, right? 4 ones. So I'm going to put 4 ones, right? But then the 2 goes up here, the 2 tens for 24. So 1 times 4 10 is 4 tens, but then 5 6 tens, right? And finally, 3 hundredths times 4 hundredths, we've already determined that is 1200. And look, watch how this relates to this. 6 times 4 is 24. 1 times 4, 110 times 4 tens is, 110 times 4 is 4 tens, plus 2 tens is 6 tens. And 3 hundredths times 4 is 12 hundredths. And there's our answer again, 1,264. Wow. Pretty amazing, don't you think so? We're going to repeat this process. Oh, no. Yep, we are. Going to repeat the process with one other model. Let me grab a piece of paper down here. And this is going to be 5,463 times 5. 5,463 times 5. What will that equal? Well, you may not find out yet, but I think it's going to equal the copycats. Well, it's not going to equal the copycats. You're just going to be copycats. Made no sense, Mr. Leggett. Sometimes I don't. Just the way it goes. So what are we going to do here? Goodness me. We're going to make a big old tape diagram, not a tape diagram, an area model. And we're going to break this into 4 pieces, right? Right? I think. Maybe 5 pieces. Okay, let's go. 1, 2. No, we'll do 4. 1, 2, 3, and 4. Okay. So we're going to put our 5 here. 5,000s up here. I'll just put 5th. You with me? 4,000s. 4 hundredths, because we've used H to abbreviate 100. 6 tens, right? And 3 ones. Okay? So let's start multiplying like we did before. 5 times 3 ones is 15. 5 times 6 tens, or 5 times 60. Think about it. 5 times 6 is 30, but we're in the tens, so we'll add a 0. 5 times 4 is 20, but we're in the hundredths, so we add 2 zeros. 5 times 5,000 is 25, but we add 3 zeros because we're in the thousands. So we have 25,000, 2,315. So what this equals is 5 times 25,000 plus 2,000 plus 300 plus 15. Oh my goodness. Or we could say 5 times 5,000, right? Plus 5 times 400 plus 5 times 60 plus 5 times 3. And go ahead and pause if need be. But we see how this breaks up. This is what we did. We did 5 times 5,000, 5 times 400, 5 times 60, and 5 times 3. Now we're just going to add them all together. Let's take a look at the old partial placement procedures. So we have 5,463 times 5. Now let's not do that reverse one. Let's just go straight down like we usually do. 3 times 5 is 15, right? 6 times 5 or 60 times 5, 300, right? 400 times 5, 2,000. And 5,000 times 5 is 25,000. We just got to add it up. So let's just take another quick look at this before we do anything crazy like adding up. No, that's not that crazy. So here's the 15. 5 times 3 is 15. 5 times 60, 300. 5 times 400, 2,000. And 5 times 5,000, 25,000. So there we have it. So we're ready to add this all up. We go 5, 1, 3, 7, 2. You know what? I didn't do the rounding, but had I done the rounding, it would have been 5,000 times 5, which would have been 25,000. So it would have been close to this. Let's just do this in the standard algorithm before we leave this part of the concept development. 5,463 times 5. 3 times 5, 15. 6 times 5 is 30, plus 1 is 31. There's my 3. 4 times 5 is 20, plus 3 is 23. And 5 times 5 is 25, plus 2 is 27. And we're at 27,315. The same. It all worked out. So that's part 2 of the concept development. Come on back for part 3, but that was a lot of math. You deserve a little break after that, I would think. So go ahead and grab some water, use the restroom, tell mom and dad you love them, feed the dog, pet the cat, run around the house, do some jumping jacks, make sure your little brother or little sister are in class. And I'll be back here for part 3 of the problems of the concept